We will use a similarity transformation to obtain an explicit solution of linear dynamic systems. Let's consider a matrix A, a n by n matrix, that has n eigenvalues and n eigenvectors. In general, eigenvalues and eigenvectors are going to be complex, but sometimes they can be real. We write down all the equations that define these eigenvalues and eigenvectors. You have a matrix, a square matrix A multiplied by a column vector, and the result of this is going to be a column vector of n terms. So we will combine all these equations into a single matrix equation in the following way. The first equation is going to be placed in the first column. This left side is here, and this is the right side. We continue with the second equation that is going to be placed in the second column. And we continue in that fashion until the very last column. We have obtained a single matrix equation that involves all the eigenvalues and eigenvectors of the matrix A. We will rewrite this equation because we can factorize from the left by the matrix A on this side of the equation. So you have A times this matrix that is formed by the eigenvectors of A. On the right side, we can also factorize by the matrix of eigenvectors, and we can prove that on this side, you will have this very special matrix that is diagonal, and in the diagonal terms, we have the eigenvalues of A. We will call this matrix of eigenvectors Q. And this matrix, diagonal matrix with eigenvalues, is going to be called capital lambda. We will assume also that the eigenvalues are all different. And therefore, we can conclude that the set of eigenvectors are linearly independent. Therefore, the columns of Q are linearly independent. The determinant of Q is different than 0, and also Q is invertible. Because Q is invertible, then this equation, A times Q equals Q times capital lambda, can be written in two special ways. If we multiply from the right by Q inverse, then we have this equation. If given lambda and given Q, we can obtain A. Or if we multiply from the left by Q inverse, we have this second equation. Given A and Q, then we can obtain lambda. A and lambda are called similar matrices because both have the same set of eigenvalues. In a different video, we will use this concept of similar matrices. I will show you how to obtain an explicit solution of linear dynamic systems using a similarity transformation.